Well, here on the bench we're testing some 807s. This is to do with the 50 watt monoblocks. I'm trying to find a load of 807s that all look much the same, that test good. And to test them, which I've been trying to do for the last few days, is turning out to be a bit of a freaking nightmare. So I'll just start from the beginning. So I started out using the valve tester that you've seen me build recently, and was getting anomalous readings, meaning that when the valve was first sort of heated up and everything, I'd start to get a cathode current, and then the meter would just read nothing, which is sort of what I had a bit before, and that's the reason I sort of put it to one side for a while. So I thought, right, okay, fuck the valve tester off, let's use all the power supplies that I've got, meaning my big bench power supply to provide the high voltage, another power supply to provide DC heater voltage, and me for now L35 to provide the bias current. And I was still getting anomalous readings. So today I thought, right, okay, let's fucking go back to basics. I do wish this bloody thing wouldn't squeak. There we go, it's a little bit better. So all I've got, right, is a bloody Gret Tech transformer, a couple of bridge rectifiers, and that's it. Oh yeah, and a couple of capacitors. You can't get much bloody simple as that. Now then, the high voltage winding should be separate to the winding which I'm using over here. So I've got a 15 volt winding going through a bridge rectifier into a 470 microfarad capacitor, and then that's the bias voltage. The AC voltage for the heaters is just coming off like another winding, and then I've got another winding with a bridge rectifier going into a 100 microfarad 350 volt capacitor for the high voltage. I've got the screen grid and the anode strapped together, so we're testing it as a triode. Right, now I've got that off my chest, let's go and bung a 807 into this very simple test setup and see what happens. The test setup is just as simple as it could possibly be. It's a UX5 valve base with a 10 ohm resistor going from ground to the cathode. So we're sensing a voltage across the 10 ohm resistor to see if we've got any cathode current. Right, now let's bung a valve in. Now this valve is one of 3 that I've tested that have all come out of boxes. These should be new old stock. Yeah, new old stock. Should be fine. Maybe one will be gassy. So there's a valve. And then what I'm going to do, just make sure my test setup is right. One moment. Okie doke. This one here is measuring the voltage across that 470 microfarad capacitor, i.e. the bias voltage. This one is measuring the voltage across that 10 ohm resistor, i.e. the cathode current. I'm just going to point you down, there'll be a bit of squeaking. And I haven't connected the top cap to the anode yet. Back to there. Right, so I'm going to turn it on so the heater is on the 807 and the bias voltage is applied. So there's our, it should be about minus 20 volts, but the HT is a little bit less than 300 volts, which is what I wanted to test it at. Bias voltage, there we go, nearly 20 volts, and it's reading current across that resistor, which is weird because there is no HT applied. Now I'm going to put the top cap on. Watch this meter. See, it jumps to 40 volts and we're getting no current at all across through the 807. What the F-U-C-K? What's that all about? Okie doke. Click it off. Somehow this capacitor here has been charged up by the voltage here. How can that be? Surely there isn't that much leakage current going from the anode and the screen into the control grid, or is there? Right, what I'm going to do, I'm going to discharge all the capacitors with my discharging doodah. Right, it's a high voltage capacitor discharged, and that's the bias voltage capacitor power supply capacitor discharged. Pull the cap off. Now pull the 807 out. Now then, one moment. Now this meter, I've changed the probes. I've got like me, you know, these probes, instead of like the sort of ones going straight to the test setup, I'm gonna probe pin 4, which is the cathode, and pin 3 I think it is, which is the control grid. See that, look? Oh, and we're getting a voltage reading there. Let's bring it on resistance. Sorry, that's some continuity. There's a resistance. But did you hear that? It just bleeped. So we've got it showing about 3 mega ohms. But that is enough leakage between those two pins to, I think, charge that bias capacitor, the bias power supply capacitor up. Right, let's see if we just take something off here. I'm just going to take a lead off, which is going from the negative of the capacitor, bias capacitor, to the, where do you call it, to the valve base, and we're getting nothing. Right, and I'm going to collect that back up. Resistance. Right, just so you understand what the fuck I'm on about, this here, this lead, this jump lead is going from the negative of that capacitor there to this nail that I've just nailed in the bench, just for, you know, so I can solder onto it and all the rest of it. So that's going from that capacitor there over here. Take that off, test the lead, test those two pins, pin 3 and 4 of the UX5 socket. I'm getting nothing. Connect that back up. I'm getting about 3 meg. So what I thought was a isolated, galvanically isolated supply between the bias supply, the high voltage supply and the heaters isn't. This is the third setup I've tried now, and this is driving me absolutely bloody nuts. And surely the 3 different methods that I've tried, the valve tester, homemade valve tester, the various power supplies, and then this power supply, all can't be at fault. All of those 807s cannot be knackered. What the fuck is going off? I'm starting to go a little bit, yeah, wobbly in my mind here, because surely they all can't be at fault. Let's think about this logically. This base here and this setup, this bit of wood and everything, is only common to two of the methods that I tried, albeit the various power supplies, which should be isolated. It's common to that and to this here, this power supply here. But it isn't common to the valve tester, but we were getting similar anomalies. So what I was getting with the various power supplies was as soon as I applied HT, high voltage, to the anode of 3 807s in question, then this power supply went gaga, basically went whacked over to about till it was reading 40 volts, which is common to this other thing here. So I'm just waffling out loud, hence why I've got this diode here. Originally I was feeding the voltage, the bias voltage from that power supply through this diode. This diode should only conduct one way. It shouldn't let current go back into our power supply. As mentioned, I'm scunnered. I am confused and I don't know what's going off. I need to find out why. Here we are the next morning. It's gonna squeak, I'm sorry. Oh, it's not so bad. I've replaced the 15 volt winding on the big tech transformer with another transformer, same setup, 15 volt on the secondary. We get 20 volts bias. Right, this is reading the bias voltage, this is reading the current across that 10 ohm sense resistor, and I've just had a thought about that 10 ohm sense resistor. So we're on 20 volts, 21 volts bias. The valve's warming up, start to get cathode current. Watch. Then suddenly that jumps and suddenly that goes low. So somehow current is finding its way into the control grid, back into the power supply, charging the power supply up, the bias power supply up, and then obviously because the control grid voltage increases to minus 40 volts, then the cathode current, anode current drops because it's going into cut-off. Right, I've just had a thought while I was making, waffling on there. Could it be that this sense resistor here isn't 10 ohms and has gone high? I've had that before. Let me check that out. One moment. Right. Safety first. Discharge all the capacitors. That's the high voltage discharged. And that's the bias discharged. Got me other meter. Got swap the leads over. Let's have a look. Alright, I've got it on continuity. Wrong one, you dipshit. Right, and that's reading 10 ohms. It hasn't gone high. Okie doke. Right, success. What I've done, I'll show you what I've done to stop that, although it still must be doing it. So we've got minus 20 cathode voltage. I hope you can see that. And we've got, although it's jiggling about a bit, about 30 to 25 milliamps to 30 milliamps on the cathode voltage. Right, now I'm going to just take a jumper off here. Right, and that's interesting. See how that's just dropped? Just going to put that back. Right, what I'm going to do, I'm going to just turn everything off. Now you see how that's suddenly gone up to like 87 milliamps. Let's just leave that there a minute. I'm just trying something. Well, I'm going to come back to you in a minute because this is just boring. Interesting. Right, I'm going to turn this off because I'm not sure what's going on. So what I just did to stop that fault where the bias power supply capacitor gets charged, I just put a diode there so that it can only conduct current one way. That stopped that. And then also what I've got is a 1 mega ohm resistor which has just got this jumper lead here, this red jumper lead across it, so that it's shorted out. And then what happened was when I took that jumper off, you saw that the cathode current went suddenly down, and then when I put the jumper back, shorting out the 1 meg resistor, then it sort of came back. The cathode current came back, but at a higher current. And I shall have to get out a bit of paper and all the rest of it and try to explain this. Alright, is that gonna... Come on, focus, you swine. Right. Here's a valve. Beam Tetrode. That's our anode. That's a... What do you call it? Not suppressor, is it? Screen grid. This is our control grid. So I'm just sniffing things. So I thought I could smell something. This is our cathode, and we've got a 10R sense resistor. That's going to ground, and we're reading the voltage across this to find out our cathode current. In between there and ground, so we've got a high voltage, got a volts, and then here, between here and the control grid, we've got minus 20 volts, and then we've got that 1 mega ohm resistor there with a jumper across it, which is basically a switch. We'll just forget this here. This is basically connected to that. So what I was doing when I was taking the jumper off that, I was putting a 1 meg ohm resistor between the power supply and the control grid. And what that is it's a test to see if the valve is leaky. What that 1 mega ohm resistor does is to test if the valve is gassy. What does gassy mean? What is a gassy valve? When a valve is manufactured, all the vacuum is pumped out of it because the electron flow works better in a vacuum, right? But you can't get every single molecule of air out there. So what it has is a getter. See these two little like flying saucer type things in there? They are filled with powder, with some sort of chemical powder, and then what they do when these are manufactured, they get a big induction coil around the valve, around the tube, whack a load of current in, that flashes off this chemical, and that takes out, hopefully, the last tiny little bit of imperfect vacuum and creates a really good vacuum inside the valve. And you see this silver in, that's what it is, that's the getter. Now then, over time, well these were probably made what? Some of these valves out of these boxes might have been made before the Second World War, or during the Second World War, or not long after the Second World War. So they've been sitting there doing bugger all for years. Over that time, the seal between all the pins, the top cap and everything, has failed. That's what I think is what's happening here. And so it's letting, not much, but a few air molecules in there, and so this is what's called a gassy valve. The behaviour we've been getting is classic of a gassy valve. So because the vacuum is imperfect, we're getting current, control grid current. There should be no current flowing into this grid, into the control grid. The screen grid, yes, a little bit. About 1/10 of the total valve current draw goes into the screen grid, but the control grid should be bugger all, like a few microamps. By putting that 1 meg ohm resistor there, you get a voltage drop across there if there's any grid current, control grid current, and then as a result of that, the bias across the valve changes, and therefore the cathode current changes. What should happen if we've got a good valve? When I take that jumper off across that 1 meg ohm resistor, there should be no change in cathode or anode current, no change at all. And because there is, then that valve is gassy. What is surprising me is that I've got 3 valves that I have tested before in the past of being reasonably okay, and all 3 are showing that they are gassy. So next, what I'm going to do is I'm going to pull a valve off the 50 watt amp, because this is what I'm trying to find some decent 807s and test one of those and see what that tests like. Here we are the next morning. There's the meters, and can we see that? Yes, we can. Got an 807 from the 50 watt amplifiers up. I don't know why I keep calling them 50 watt. Anyway, as far as I know, that's a good 807. Let's bang some voltage on it. See, we've got minus 20 volts on the bias. Cathode current starting to come up. That's very healthy, 1.5. That's very, very healthy, 150 milliamps. And the bias has gone down interestingly. And the cathode current is jiggling about a bit. But, I mean, that tests okay. So I was starting to really doubt my own bloody sanity there. Right, well, at least we know that's a good one, and it's sort of settling down now. So I just removed the jumper from the bias there. It's changed a bit. Which still means that that one's a little bit gassy. I'm going to have to look into this test, because this test method of putting a 1 meg there in the bias feed, as it were, comes from a couple of old PDFs I've got, so we need to look into that. Anyway, well, that's settling down, that's showing really good emission, and it also shows that our setup is valid. Nothing wrong with the setup, but that also means 1, 2, 3, 4 807s are fucked. Oh, this one's interesting. I thought this one would test bad, but it's testing alright. Yeah, hold on, look. See that? Quick. See that? That looks like the screen grid pulling too much. See that glow inside there? So that means that the anode may not be connected. Uno momento. Yeah, thought that was testing okay, but that must have been just pulling that on the screen grid. I'll get a resistor out of the drawer, stick it on the screen grid thing there, and we'll see. Well, that's 100 ohm tacked in there on the screen grid, and so we need to move some leads, don't we? We need to put one there, and where's that other one gone? That one. And we'll see how much is being pulled by that. Okay, right, okay, so we're not reading, one is reading the anode current and the other one is reading the bias current. Sorry, the screen grid current. So this is reading the current going to the screen grid. This one is reading the current across the cathode. Okay, and that's interesting. As you notice, the cathode current has gone down from 1.5 volts. Okay. That is very strange. Well, maybe that was oscillating then. Maybe that 100 ohm resistor on the screen grid there has just calmed that down a bit. I'm going to carry on anyway, and I'll turn you on if there's anything interesting to see sometime later. Try again. Sometime later, and we've had more success-ish. Over on the left hand side we've got 1, 2, 3, 4, 5, 6, 7 807s that test rather good, and over on the right hand side we've got 1, 2, 3, 4, 5, 6, 7-ish that test okay, but not as good as the ones on the left, which is better than what I thought. I mean, a lot of these are pools and what have you, so yeah. I can now go forward and pop some of these into the 50 watt amplifiers and get them so they're all matched aesthetically wise. Talking of aesthetics, I'll just pull a couple of these out here. If you notice, they've both got those ribbed sort of top caps, and then if you look at the bases, they sort of seem to be made out of a Bakelite or plastic that's got like lots of bits in. And this one's called marked Westinghouse. The Jan is like a joint army navy thing, made in Canada. So I think these two could safely be said to have been made in, I don't know, it does say there, look, made in Canada. Can't really see what that one says there, the writing's come off. Yeah, but they look like they came out the same factory. The anodes are the same, that crimp at the bottom is the same, mica wafers are the same. These are two of the valves that came from my mate Joe. Now this is what I did find surprising. One of them, which I thought was dead, isn't. And this one with the funny getter on it, which I thought was knackered, seems to test okay. You can't see the anodes on there very well. Don't know what that writing on there means. DO. Yeah, see if I can find any of it interesting. Thingy doodahs. Right, yeah, see, that one I thought was dead, actually tested okay. Yeah, they all seem to have pretty much the same sort of anodes, mica, I mean the 807, from what I understand, I mean it doesn't matter where it seems to have been made. Some have like different getters. You see those getters down there are like a folded piece of wire. I don't know, let's try not to mess these up. And that's wire too. I can't find the damn getters on these ones made by Radiotron in Australia. Can't actually see the getters. Getters are obviously behind the gettering. Oh yeah, you can just there, look. It looks like a big sheet of metal in those Radiotron ones. Just make sure I don't get them mixed up. Oh no, right, oh no, they're the Westinghouse ones, aren't they? And then we've got all these ones that failed, which absolutely was driving me nuts. Right, if you see this one, made in the USA, the anode structure is bigger. It's got like 4 holes where the two sides of the anode are crimped together, and it's got this one here has got different mica holders, round mica holders, round ceramic holders, and then it's got those, you can see, like flying saucer type getters, and this one I can't see any sort of getter on there. Oh no, they're there, look, they're like those little sort of like a bow saw shape getter. So why these ones tested so weird, I don't know. What I might try and do is see if I can make some sort of induction device and give them a zap and see if we can get rid of some of the gas. I mean, like this one, it's got hardly any getter left in it at all, just a little bit of silvering down there, and I don't know, maybe there is a bit of chemical left on that bar there on the getter. We'll see if I can get them back to life. Well, here's a puzzler. I'm testing the 4 that I'd wrote off as too gassy, and they seem to be working. Although I suspect this one is a bit weird because it's reading a very high screen grid current. So all I can assume is that my test setup was incorrect and the diode sort of fixed it. Right, I'm just pulling that. Wow, see that, look, me pulling that jumper from across the 1 meg resistor makes it go ballistic, and that's way too much. Right, that is very strange. So I presume that this one is a little, well, quite a lot gassy, but what I'm going to do, I'm just going to leave it on for quite a little while and see what the crack is. I keep getting this urge to just take the bias off, but I think that would be a little bit foolish. I don't want to knacker the transformer up and everything, so yeah. Oh, that was a bit of a deep dive into testing 807s. I've no idea why, when I first tried testing them, we seem to be getting grid leakage or some sort of high voltage leakage into the grid, which was then charging the bias supply up. I've no idea what the hell was going off there. And just when I was like full of despair and everything, the test setup seemed to work. So I've still not really got to the bottom of what the hell was going off. Also, it was a bit surprising because, like a lot of what I thought were dead or knackered 807s that are tested previously then tested okay. Yeah, I don't know, there's some weird shit going off somewhere. Testing valves, there's a lot more to it than what you think. You can bung them on one setup and they'll test such and such a way, and on another, yeah. So who knows. Anyway, all the 807s are in the monoblocks. I'm just sort of burning them all in, or whatever you call it, running them in, testing the amplifier and all the rest of it. So bit of a long video, bit boring in places, but if you like testing valves and like getting your head around shit, well, there you go. Anyway, thank you very much for watching. Take care of yourselves. Ta-ra for now.